Hi everybody, my name is Lizzie Eigenberry, and this is my final project for MIS 670. There we go. Okay, we started the project by importing packages and importing the data, which I won't show you because it's boring. These are my opening statements. The problem statement, we want to determine what qualities of those contained in the IMDb's dataset are most influential in determining how high a movie scores. The determining of qualities that cause IMDb scores to go up would be very important to filmmakers and film production companies, as they, of course, want to maximize profits. So, as a business context, the business value, it's very valuable to the aforementioned clients. It's important to the film industry. Maximizing those scores is not only a good thing for profitability of the movie, but it's also influential on individuals' popularity, which would mean if their popularity goes up, the value of their skill set goes up. So this means a lot to a lot of people. So let's get into data processing. Looking at clarity, integrity, and consistency. Here's the quality. So there are a lot of missing values, as you can see listed here with this code. We're going to fix that with the data cleaning section. I start this section by replacing the underscore in the titles, or in the column titles, because I don't like it. And now we, in the project, remove the missing values. I replaced missing values in these columns with means and modes. Along with in the float values, I replaced them empty columns, empty entries with the mode, just so that I could leave the data set as intact as possible and we could do a more powerful analysis. After I did that, there's no missing values. We're going to do some transforming now. We're going to separate all those genres and plot keywords that were separated with a line into different columns and compare them to their IMDb score, just to make the dataset make more sense. Here you can see plot keywords. Now some visualization and business intelligence, starting with the numerical values and correlation. So here's a correlation matrix. We're comparing all of these different X variables with IMDb score. The highest correlation value is with num-voted users. These are the top 5. We look at these throughout the entirety of the project, but I will show you the correlation between num-voted users and IMDb score. It's very clearly positive, looks statistically significant, but we can test that later. So that's probably going to be very influential. Categorical variables include color and content rating. We can figure out which of those is the best and compare them and see if they have an impact on IMDb score. Here's content rating, box plot. See the average of each of the different content ratings. The categories with the highest scores in the graph are M and approved. We can't tell if they're significant or not, but there is difference. So float values, here we can just look at the top listings from each different category. Here's language, the top in language being with a filled value, being Telugu, I believe. And here's the top 5 countries. So now let's get into the regression analysis. We're starting with the sklearn model. Here we're going to find the coefficients in this regression analysis, and I joined them with our column names here. You can see the coefficient right next to the column it belongs to, each x value. And now we're going to evaluate it. Here's some visualization. Looks like it explains about half of the data. The other half, it's way off, so looks like there might be some room to improve. And the R-squared value does reflect that. R-squared, or accuracy rating, turns out to be about 34.7%. That's not impressive. Pretty low. It's a poor regression model. Now we're going to try stat model, regression model. Here we build it, we zip, we join, I suppose, the coefficients with their column names again, just like we did before. And here is the accuracy rating. So we have 34% about. Not any better. Definitely not good. Probably won't be using that one. So let's see what we can do to fix those two. I used lasso first. We lasso it, and still 34%. not any better. Actually made it worse. So here's the K3 method. Here we're going to pick the most important columns and then try it again. Maybe we can eliminate some of that noise with all these extra X columns. Chose num critic for reviews, duration, and num voted users, just like we talked about earlier as being important X values. We run this again with only those 3 variables, and we see that the R-squared goes down significantly to 27%. Very poor regressive model. You would never use this in real life. So regression overall was not very effective in predicting scores of movies, but if we want to pick a winner, for accuracy, it's a tie between sklearn and the stat model. So classification. First we start by creating bins for the IMDB scores: bad, okay, good, and excellent. Then we work on a decision tree model. So we build that model. We can see here with the statistics test that the difference between those different labels is significant. So that's good. We can continue, build the model, and test the accuracy. Here we have 65.84%, or a lot better than regression. Still not great, but it is over 50%. We're moving in the right direction. Here is just a confusion matrix to explain what it got right, what it got wrong. It got about 64% right, so that's okay. Not perfect, best modeled so far though. Now we try KNN, another method. Same accuracy score. Didn't get any better, didn't get any worse. And finally, we try the random forest regressor model. This model comes back with an accuracy rating of about 73.89%, or over double what we got in the regression equations. It's definitely the best that we see in this project. So that's exciting. Random forest regressor model is the best that we see. Here are the columns that it finds most important in calculating IMDb score. Num-voted users, duration, and budget are actually the most important for this model. Here we just compare what Random Forest came up with to what the actual bin was. Pretty good, about 75%. Now finally, clustering analysis. We're doing k-means. I chose to have 3 clusters as there are only 2 clusters that significantly differ between scores. Here's that implementation of that model. Here's the count. So cluster 0 has over 3,000, while cluster 1 has 1, and cluster 2 has 3 different rows that fit into each cluster. Here's that graphically represented. It's not very good. That wouldn't be very effective in predicting scores. Here's profiles from each cluster if you'd like to look at those closer. Overall, this is that clustering was not a very good way to determine IMDb score. So summary. Overall, we determined that using machine learning tools to predict IMDb score was not as easy as it seemed. We had lots of data, but we weren't even able to get an accuracy score over 80%. So it was difficult. Here's regression. Here's the summaries of each model's accuracy. This model, the conclusion, this type of analysis is not impressive. Accuracy rates for these models are far too low to be realistic predictors. And we really shouldn't deploy regression models in these business decisions because they aren't very accurate. For classification, here you can see the accuracy for each model that we tried. We finally came to random forest regressor, which can accurately predict the bin for over 74% of movies, twice as accurate as regression, and is the best that we see in this project. Did a pretty good job, could be realistically used. It should be situationally decided if this should be used in business decisions, though. Finally, clustering k-means. Over 3,000 entries, it created cluster sizes of over 3,000, 1 and 3. That means that almost all movies would fit into cluster 1 and would be just assigned the mean of the entire database. So, kind of a waste of time. If you're going to do this, you might as well try the naive approach using the means from the dataset and bypass all of this difficult creation. Final decision, random forest regressor. Here's the top 10 important variables. you can see here. So that's what filmmakers would want to look at most closely to make a good IMDb score movie. Here's my references. Thank you for listening, and you have a great day.